to use algebra tiles. Now, first, I think it's important that we define each of these, especially if students have never used them. This little square represents 1 unit. Each dimension is 1, and the entire square here is 1 square unit. Now, this bar here is x, and you'll notice the dimensions are 1 in one direction and an unknown amount in the other direction. If students tried to measure this side of the x tile, they could line up the units here, but it would not come out perfect. So we say that it's an unknown value. And since the dimensions are 1 by unknown, that means that we do not know the value of x. So it's kind of important here that the x tile does not match up perfectly to a certain number of our unit tiles. All right, and then this square here, the larger square is x squared. If we measure each dimension, its length and width are both x, which gives us x squared for its value. We're going to start off multiplying two binomials, and it's important that students realize that multiplication is connected to area. When we multiply two factors, the factors are the width and the length, and the area represents the product. So if we want to multiply x plus 2 times x plus 1, we're going to set it up with our dimensions along the top and the side here, and then when we fill in the area, that is going to be our solution. When we multiply these two binomials, the product is the area that we find inside. Pause here if you want to try it out. Okay, x times x gives us x squared here, and you can see how it matches the dimensions. And then we're going to multiply x times these 2 units. So here we have 2x. Then we're going to multiply x times this 1 unit down here, which gives us another x. And then we'll multiply 2 units by 1 unit, and that will give us 2 units here. Now here is our solution represented as the area, x squared plus 3x plus 2. Algebra tiles really make polynomials a tangible topic. Now, if this is the first time students have worked with multiplying with algebra tiles, I'd recommend doing several more problems, but we're going to move on and try to find factors. So with factors, we're doing the opposite. This time we're going to be given the area and we have to figure out the dimensions, similar to what we did with the rectangles earlier, but now we'll have x's involved. Okay, so let's factor. And I love factoring with algebra tiles because it just feels like it's a puzzle. It doesn't feel like we're trying to follow some steps or a formula or anything. We're just trying to work out a puzzle. So I want you to gather these tiles, x squared plus 5x plus 6. So you'll have your large x squared, and then you'll have 5 of the x's, and then you'll have 6 units. And all you need to do is arrange these into a rectangle. Pause here and try it out. Okay, hopefully you had a chance to play with these until you made your rectangle. So we might start by placing X tiles here. Again, students aren't supposed to just get this right off the bat, especially if this is the first time. It may not feel efficient, but that's okay. We don't need to stress for efficiency when we're starting out. The thinking is what is important. So then our factors are going to be the dimensions. On the top, I have x plus 3, and along this side, I have x plus 2. Now, yours may be arranged in the other direction where you have x plus 2 along the top, and that's perfectly fine. All right, let's try one more. This time, I want you to use algebra tiles to factor x squared plus 7x plus 6. Pause here. So again, we're expecting students to just play with the tiles until they get it to work. And once they do, we can ask questions like, how do the tiles represent the solution? What patterns do you notice in the original polynomial and in the factors? Could you arrange the tiles in any other way to find the factors? All right, if you have never used algebra tiles, I hope this gives you some inspiration to try it out next time you teach polynomials.